What happens when engineers stop asking, how much power does this car need? And start asking, how little car can we put around the power? Because horsepower by itself doesn't tell you the whole story. A 2,000 horsepower car sounds terrifying, but if it weighs 2.5 tons, well, congratulations. You've built a very fast apartment. Today, we're counting down 10 road-legal cars with some of the most ridiculous power-to-weight ratios ever put into production. We're talking hypercars, limited editions, screaming V12, twin-turbo V8, and some absolutely insane electric machines. For this ranking, we're looking at horsepower per kilogram, using the quoted maximum power and the manufacturer's stated vehicle weight where available. And there's an important disclaimer before we start. Car manufacturers don't always measure weight in exactly the same way. Some quote dry weight, others quote curb weight or unladen weight. So this isn't a perfectly scientific apples-to-apples laboratory test. But the numbers are still completely insane. And trust me, the cars get progressively more ridiculous. Let's start with number 10. Number 10 is the McLaren W1. McLaren's W1 is the successor to two rather important cars, the legendary McLaren F1 and the hybrid P1. So no pressure then. The W1 combines a 4-liter twin-turbocharged V8 with an electric motor, producing around 1,258 horsepower. And the really impressive part is how little car McLaren managed to put around that power. The quoted weight is about 1,399 kilograms, or roughly 3,084 pounds. That works out to approximately 0.90 horsepower per kilogram. And then there's the torque, 1,340 newton meters. That's 988 pound-feet. Let me put that into perspective. You have more than 1,200 horsepower, nearly 1,000 pound-feet of torque, and you're asking 2 rear tires to deal with it. Good luck to those tires. But McLaren didn't just throw a giant engine into a carbon fiber shell and call it a day. The W1 uses active aerodynamics, active suspension, and a huge active rear wing. In its more aggressive modes, the car changes its aerodynamic configuration and generates enormous amounts of downforce. And that's where things get interesting, because once you get to this level of performance, horsepower isn't everything. The question becomes, can the tires actually use it? Can the suspension keep the car stable? Can the aerodynamics keep it attached to the road? And can the driver keep their breakfast inside their stomach? McLaren's answer to all three appears to be, let's find out. Now, if you've never heard of a Spark, don't worry. You're not alone. This isn't Ferrari. It isn't Porsche. It isn't McLaren. It's a Japanese company that apparently looked at the entire hypercar industry and thought, yeah, let's build an electric one that accelerates like it's being fired from a cannon. The Aspark Owl uses 4 electric motors and produces around 1,953 horsepower. The car weighs roughly 1,900 kilograms, or about 4,189 pounds. And torque? 1,920 newton meters. That's 1,416 pound-feet. The power-to-weight ratio works out to roughly 1.03 horsepower per kilogram. And here's where electric cars become absolutely ridiculous. With a traditional combustion engine, you press the accelerator, the engine revs rise, the turbo spools up, the transmission finds the right gear, and then the power arrives. With an electric motor, you press the accelerator, and the torque is already waiting for you. The Owl has 4 motors, which also allows the car to precisely control torque between the 4 wheels. And the claimed 0 to 100 km/h time is around 1.8 seconds. 1.8. At that point, you're not accelerating. You're basically being informed that gravity has resigned. And this is still a road car. A very expensive road car, admittedly, but a road car. And the name tells you exactly what Christian von Koenigsegg was trying to achieve. 1 horsepower for every kilogram. 1 to 1. The 1:1 uses a 5-liter twin-turbocharged V8, producing approximately 1,341 horsepower. The car weighs around 1,360 kilograms, or about 2,998 pounds, and torque is rated at 1,371 newton meters. That's 1,011 pound-feet. So we're looking at roughly 0.99 horsepower per kilogram, basically 1-to-1. Only 7 examples of the 1:1 were built. And Koenigsegg didn't just increase the engine output and hope for the best. They attacked the entire car. Carbon fiber wheels, active aerodynamics, a massive rear wing, sophisticated suspension, and an engine capable of running on different fuels. This is the kind of car where you look at one component and think, that's pretty advanced. Then you look at the next component and realize they've done the same thing again, and again, and again. The 1:1 is what happens when an engineering department is given permission to completely lose its mind. And remember, this thing was doing all of this more than a decade ago. If the Koenigsegg 1:1 feels like a physics experiment, the Czinger 21C feels like the result of that experiment being conducted in a futuristic laboratory. Look at it. It doesn't really look like a normal car, and there's a reason for that. The driver sits in the center at the front, with the passenger directly behind. It's almost like a fighter jet with license plates. The idea is to reduce the frontal area and create a very narrow, aerodynamically efficient car. But the really fascinating part is how the car is manufactured. Czinger uses advanced 3D printing technology to produce complex structural components that would be extremely difficult to manufacture traditionally. And then they put a rather angry engine in the middle. The 21C uses a 2.88-liter twin-turbocharged V8 with a flat-plane crankshaft. And this little V8 revs to around 11,000 revolutions per minute. 11,000. Total system output is around 1,250 horsepower. The quoted lightweight version weighs approximately 1,240 kilograms, or about 2,734 pounds. Torque is around 938 newton meters. That's approximately 692 pound-feet. So we're looking at roughly 1.01 horsepower per kilogram. And because this is a hybrid, the front wheels are driven by electric motors. That gives the 21C four-wheel drive without a traditional mechanical system connecting the front and rear axles. And that's one of the coolest things about this car. You've got an 11,000 revolutions per minute V8 behind you, electric motors at the front, and software constantly deciding how much torque should go where. It's basically a computer-controlled argument between 4 tires. And somehow, it works. Now we're getting into truly ridiculous territory, because the Valkyrie isn't just a very powerful car. It's essentially a Formula One philosophy translated into something with number plates. The Valkyrie was developed with help from Red Bull Advanced Technologies, and the influence is obvious. The seating position, the aerodynamics, the carbon fiber structure, the obsession with reducing weight. And then there's the engine, a 6.5-liter naturally aspirated Cosworth V12. No turbochargers, no supercharger, just 12 cylinders screaming their way toward an 11,100 revolutions per minute redline. The V12 produces around 1,000 horsepower by itself, and with the hybrid system, total output reaches approximately 1,160 horsepower. Torque is around 900 newton meters. That's 664 pound-feet. And the car weighs approximately 1,030 kilograms, or just 2,271 pounds. That gives us roughly 1.13 horsepower per kilogram. Think about that. A road-legal car, a naturally aspirated V12, over 1,000 horsepower, and just over 1 ton. It's basically an F1 car that somebody reluctantly taught how to use traffic lights. And then you start looking at the details. The aerodynamic tunnels underneath the car, the extremely compact cockpit, the high-mounted exhaust outlets, the carbon fiber construction. Everything has a purpose. This isn't a luxury Aston Martin that happens to be fast. It's a race car that was forced to become street legal. And this is where the numbers start becoming genuinely stupid. The Jesko Absolut uses a 5-liter twin-turbocharged V8. Running on E85, it produces up to 1,600 horsepower, and torque peaks at 1,500 Newton-meters. That's 1,106 pound-feet. The car weighs around 1,390 kilograms, or approximately 3,064 pounds. That gives us roughly 1.15 horsepower per kilogram. But the engine isn't the only crazy thing here. Koenigsegg developed something called the light-speed transmission. It's a 9-speed transmission using multiple clutches, designed to shift incredibly quickly and keep the engine right where it needs to be. And then there's the aerodynamic philosophy. The Jesko attack is designed around downforce. The Absolut is designed around speed. So the body is much smoother with less aerodynamic drag. Koenigsegg has quoted a drag coefficient of around 0.278. And that matters because once you're trying to go incredibly fast, the biggest enemy isn't necessarily weight. It's air. The faster you go, the harder the air fights you. So the Absolut is essentially a giant engine wrapped in a carbon fiber argument against atmospheric pressure. And with 1,600 horsepower, it's a pretty convincing argument. Now, if you know anything about Lotus, you probably know the company's famous philosophy. Simplify, then add lightness. Well, the Evija weighs nearly 1,900 kilograms. So what happened? Apparently Lotus decided to simplify the definition of light. The Evija is an electric hypercar with 4 motors and approximately 2,000 horsepower. That's roughly 1,973 horsepower. Torque is an absolutely ridiculous 1,704 Newton-meters. That's 1,257 pound-feet. And the car weighs about 1,887 kilograms, or around 4,160 pounds. That gives us roughly 1.05 horsepower per kilogram. But again, the interesting part isn't just the number. Look at the bodywork. Those huge tunnels running through the rear aren't there because the designer thought they looked cool. Although, let's be honest, they do look incredibly cool. They're part of the aerodynamic system, channeling air through the body to help generate downforce while reducing drag. And then you've got 4 electric motors, 1 for each wheel. That means every wheel can be controlled independently. Instead of one engine sending power through a transmission and differential, you've essentially got 4 individual propulsion systems being managed electronically. And that changes the entire way you can control a car. The Evija is almost the complete opposite of the old Lotus philosophy. The original Lotus recipe was small engine, tiny car, low weight. The modern recipe is 4 electric motors, 2,000 horsepower, and enough battery technology to make the original Lotus engineers wake up screaming. And this is where things get really interesting, because if you've been ignoring Chinese performance cars, you might want to start paying attention. Yangwang is BYD's ultra-high-performance brand, and the U9 Extreme is absolutely not messing around. We're talking roughly 3,000 horsepower, for electric motors, around 2,480 kilograms, or approximately 5,467 pounds, and reported peak torque of around 3,360 Newton-meters. That's about 2,479 pound-feet. The power-to-weight ratio comes out at roughly 1.20 horsepower per kilogram. And this isn't just some theoretical number from a presentation. The U9 Extreme has been tested at extreme speeds, reaching a reported 496.22 kilometers per hour. That's 308.4 miles per hour. 308.4 miles per hour. At that speed, if you drop your phone out the window, it doesn't fall. It becomes a projectile. The U9 uses a 4-motor setup with independent control of each wheel. That means the car can constantly adjust torque distribution between the 4 corners. And this is one of the biggest changes we're seeing with electric hypercars. The electric motors aren't just replacing the combustion engine. They're giving engineers completely new ways to control the car. You can manipulate torque incredibly quickly. You can control each wheel independently. and you can use software to do things that would be incredibly difficult with a traditional mechanical drivetrain. So yes, the U9 is heavy, very heavy, but it's also carrying around almost 3,000 horsepower. And at this level, apparently nobody cares about scales anymore. Now we're getting into American territory, and American engineers have looked at the hypercar arms race and decided that perhaps the solution is a really big V8. The Venom F5 uses a 6.6-liter twin-turbocharged V8 called Fury, and Fury is an appropriate name. It produces approximately 1,817 horsepower, torque 1,617 Newton-meters. That's 1,193 pound-feet. And the dry weight is only around 1,360 kilograms, or about 2,998 pounds. That gives us roughly 1.34 horsepower per kilogram. And the engine itself is a fascinating piece of machinery. This isn't some tiny exotic V8 revving to 12,000 revolutions per minute. It's a big American pushrod V8 with twin turbochargers. And it's making more than 1,800 horsepower. The engine weighs around 280 kilograms. That's roughly 617 pounds. And from that relatively compact package, Hennessey is extracting an absolutely absurd amount of power. But perhaps the craziest part is where that power goes. The Venom F5 is rear-wheel drive, all of it, 1,817 horsepower, 2 driven tires. So imagine the conversation between the engineers and the tires. Engineer, we've got 1,817 horsepower. Tire, okay. Engineer, it's going to the rear wheels. Tire, I'm sorry, what? And that's the Venom F5. It's not trying to be sensible. It's trying to be fast. Very, very fast. The car was developed with extreme top-speed performance in mind. And at these speeds, everything becomes difficult. Cooling, tire development, aerodynamic stability, engine durability, even keeping the car pointed in the right direction. Because once you're approaching hundreds of kilometers per hour, a tiny aerodynamic disturbance can become a very large problem very quickly. And here we are. Number 1. The SSC Tuatara. And the numbers on this thing are borderline offensive. The Tuatara uses a 5.9-liter twin-turbocharged V8. Running on E85, it produces approximately 1,750 horsepower. Torque is rated at 1,735 Newton-meters. That's 1,280 pound-feet. And the dry weight is around 1,247 kilograms. That's approximately 2,750 pounds. Put those numbers together and you get roughly 1.40 horsepower per kilogram. That's around 1,404 horsepower per ton. And remember, this is a road car. The engine is a twin-turbocharged V8. The body and monocoque use carbon fiber. The aerodynamics are designed around extreme high-speed stability. And the car was engineered from the beginning with one very clear objective: go unbelievably fast. The Tuatara can also run on regular premium fuel at a lower output. But switch to E85 and the engine unleashes the full 1,750 horsepower. And this is why the Tuatara takes the top spot in our ranking. It's not simply the most powerful car here. It isn't. Several cars on this list make more horsepower. The difference is what happens when you combine that power with very little mass, because that's what power-to-weight ratio is really about. The real lesson: horsepower isn't everything. You can keep adding horsepower forever, but eventually the harder challenge becomes getting the rest of the car to cope with it. You need tires that can handle it. You need brakes that can stop it. You need suspension that can control it. You need aerodynamics that can keep it stable. And you need a driver who has enough courage, or perhaps insufficient self-preservation, to actually use it, So let's take a step back. We've just looked at 10 road-legal cars ranging from roughly 900 horsepower per ton to more than 1,400 horsepower per ton. We've seen screaming V12, twin-turbo V8, hybrid systems, four-wheel electric powertrains, 3D printed components, active aerodynamics, torque vectoring, and enough torque to make a heavy-duty truck feel slightly embarrassed. But there's one thing I want you to remember. Power-to-weight ratio is one of the most important numbers in a performance car. But it isn't everything. Horsepower doesn't turn the car. Horsepower doesn't create grip. Horsepower doesn't stop the car. And horsepower definitely doesn't make the driver faster. In fact, once you get to this level of performance, the engineering challenge becomes finding a way to actually use all that power. Because there's a big difference between having 2,000 horsepower and having 2,000 horsepower that you can actually put onto the road. And maybe that's what makes these cars so fascinating. They're not just engines with wheels. They're enormous engineering projects designed around one ridiculous question. How fast can we possibly make a road car? And judging by these numbers, the answer is apparently very, very fast. So which one would you actually choose? The screaming V12 Valkyrie? The insane Koenigseggs? The electric monsters? The American twin-turbo V8S? Or would you just take the Tuatara and accept that your driver's license has entered a very dangerous relationship? Let me know in the comments. And if you enjoyed this video, subscribe, because there are plenty more cars out there that make absolutely no sense. And we're only getting started.